All right, here we are. Welcome back. And let's see. I'm actually, if I pause and address something off screen, I'm simultaneously streaming this on Twitch, and since I am a nobody, and I doubt anybody will just randomly pop in. But if they do and ask a question, I may stop and address that. But I'm trying to hold myself more accountable to not play around as much while I prepare for these recordings, and so we want to get them out there to you. And anyway, yeah, so we're going to pick up where we left off. Last time we got to the point we could make sure that the compilers was actually compiling, and now we want to try to execute, or rather compile to bytecode, and hopefully be able to execute the program. And so, yeah, we're just going to jump in. Well, first, I want to point out one of the last things that I did in this. At the end, I said I was going to update the documentation, which I did. And let me just say, what would be a good example of? I'll just show you the file. So WSL, hello. WSL view. Where is this? This is under docs, HTML, index. Yes. Okay, here we are on the documentation. And I added file level documentation. What do I mean by that? Well, of course, I'm only documenting the includes at the moment. I'm going to experiment to see if there's any advantage to document the .cpp files. But right now I'm just documenting the includes. And if I just look up, AST, there we go. And up at the top, you now see that there is this file, and it just tells it what the file is about. And what that did for us is on the right-hand side now under files. Before, location.hh had done this for us, and that's when I first noticed it. And now for each file, it gives us information about it. And if we click on it, then it, we can, somewhere we can get there. Where is this? There we go. Include ast.hpp, and it'll show us the source code minus the Doxygen comments. And so, and we can click on the line numbers to get the documentation for this AST node integer, for example. Pretty cool, pretty nice. But the most powerful thing that it does is if we go to our class list now, and I'm just going to go to Tang base. Why not? And okay, I thought it would show up here. I'm not seeing it. Or is it this on this page? No. It's not there. Oh, the cool thing I was going to show you, I'm not seeing it. Well, you know what? I can show you it in one other way, and that is WSL view docs/latex/refman.pdf, and of course this is the PDF file that is automatically generated. And I did hit enter, didn't I? The WSL just crashed. I've not seen that happen before. Okay. Having to reopen it. That's wild. Okay. I'm going to do this again. Docs/ latex/ refman.pdf. There we go. And actually, yes, it opened up to the actual view I wanted to see. Maybe that's it. It's in the file reference. But it shows Tang.hpp and what it includes, and I get this nice diagram. Why do I care about this? Because I need to verify that the make files are, for example, when I compile program and pound include program, I need to know that, hey, I also have to watch for changes to asd.hpp and error.hpp and location.hh. And I need to add those to the make file. So this is just, it's a nice tool for that purpose. So evidently it's in the file reference. Okay. Now, on to what we're trying to do, and that is we're trying to get started. Yes, we're trying to get started with, we want to be able to compile the program that we're creating. But in order to compile it, what are we going to compile it into? And the answer is opcodes, operational codes, and or bytecode. Bytecode is made up of opcodes plus the instructions. And yes, so that's what we're going to do. So what we need to do is include, and this is just going to be called opcodes. Yes. Now this is not going to have a CPP file. This is just a header for the opcodes, and I'll worry about the file. No, I'll just do it now. Sure, why not? And let's see, we're going to say, not namespace Tang, and I'm going to have to look this up. Might as well do it now while you're watching. And we can do it, let me do, this is probably better. I prefer incognito windows. There we go. And what are we going to search for? We're going to search for C++ class enum. There we go. And I just want to double check it's enum class, and that we got it in, as you can see, C++ 11. So enum. Yeah, I was looking for the enum class example. This works. Enum class, and this is going to be called opcode. And I always forget the closing semicolon, so I'm putting it first. And the first one that we're going to do is op integer. And can I leave a comma there? I hope so. Let's see if it works. And in we can do 3 slashes and this less than to tell Doxygen I'm writing documentation. So I'm going to say push an integer onto the stack. That's what it means. All right. The other thing is, do we want to... I think that's good for the moment. I'm writing this, and I'm trying to use buffers now. So if I do include and so we've got our AST nodes. What we're going to do, we're going to need to compile it into opcodes. Let's go from there. Okay. Include should be program.hpp, but I don't think it's going to let. Nope. Huh. Okay. Oh, that's why. I was using Control B. So, sorry, I'm trying to learn how to use these buffers. And a buffer is simply a kind of like an area of memory that you can switch between. So if I open up opcodes again, it's :E for edit in a new buffer. And now include program.hpp. There we go. And if I ask to see my buffers, I have buffer 1 and buffer 2, you can see in the lower left-hand corner. And now if I do :B1, I go there, :B2, switch back and forth. That's the point. All right. So I've got this class called program. That's fine. I need to have another class, and we're going, no, I don't want this to be a class. I want to have, this is going to be a vector. There we go. So bytecode. Is that just one word? Yes, I'm going to use it as one word. Is a standard vector of uint 64t. And what is this? This is not represents, it is the bytecode. Contains the opcode, sure. All right, so a program now should have a bytecode. It needs to be protected, of course, but we'll just put it... This is going to be... program, there we go, and we're going to call this as bytecode. Bytecode, sure, why not? Okay, so I don't like what I did up here in calling compile. Well, we called something compiled, but we're going to now change it. So it said compile the code. That's not exactly what we had written. We had actually written compile the AST. Or the code into an AST. And that's not compiling, that is really the parsing. So we're going to fix this. So compile is actually going to be compile the AST into bytecode. Yes. And we're going to add a new one that is should I say it like that? Compile the code into an AST. Can I do that? Can I use compile like that twice? Void parse. It should be parse. Parse the code into an AST and then compile the AST into bytecode. That's better. Parse and then compile. And then we've got this bytecode thing called bytecode. All right, and now we need to edit the source/program. And now let's make these changes. So we called this compile, but it's actually parse. And now we need a compile. All right, now I'm going to fix some stuff because we don't need that. We don't need that. Should all still work. And first we were saying compile. This should be parse. Now, at the moment this should all still work fine. I'm going to go ahead and do my make watch-test. Recompiled everything. That's always a good thing. I like to compile often. We saw earlier, a couple episodes ago, when I spent 2 hours programming and didn't get to compile because we were setting up Flex and Bison and all of that stuff, and then it took forever to track down all those parse errors. So, yeah, compile often. Now, what does it mean to compile? Well, first of all, we'll say if this AST, right? Yes. Then, and I know I could just say compile, but I prefer this way. It's not doing anything. Okay, well, I mean, it's not supposed to. I mean, no errors, good news at this point. Now, what do we want to do? If we're in compile, that means we can do something with the AST, right? No, this is internal. Nobody's going to call it. I don't need to check for its existence. We're going to assume it's there and go. AST, which is itself a... Yeah, I can do this. It's going to have a compile, and I'm going to pass it this arrow bytecode. Is that right? Do I need to pass it anything else? It's a very good question. I'm going to check my notes. I think I would rather have access to this itself. Yes, I'm going to pass in the program, and we'll do it as a reference, so it doesn't matter that we're dereferencing it. And of course, it's saying, hey, it doesn't have something called compile. That's fine. We're about to fix that. So I'm going to now edit the include slash, not program, but the AST. So the public, there's going to be a compile. Don't know why I'm doing it this way. No, if I do it like this, that should be fine. It doesn't return anything, but it's going to be a virtual void compile, and well, I'll say and it will definitely be a const. There we go. Now it doesn't. It says I don't know what this is. So pound include program.hpp. There we go. Okay, this is an interesting problem. Program needs the AST definition, and AST needs the program definition. We should be able to do class program. Will that get us by? Yes. Just telling it, hey, we promise that it's going to exist at some point. We're not redeclaring it. It's just an empty prototype. Okay. And we're getting a segmentation fault. Okay. Is it because I don't have the compile? I'm not sure. We're about to find out. Source/program.cpp, and no, we need it in the AST. That's where we are. Okay, so the buffers, four is there we go. And that's what I need. And that's why you do this. As you see, it's now I can copy and paste between. Okay, I don't need virtual. But I do need AST node, compile. That was unfortunate. I prefer to keep things together, so the AST node up at the top, AST node integer here. And of course, AST node integer, we've got a dump. Now we've got to compile that. We're promising should be an override. And it doesn't like that. Just go from the start. So we're compiling AST.cpp, AST.hpp says AST node is not. Why is AST node? This think we have the same problem as earlier, and if I just say unused parameter. Okay, we're gonna have to deal with this unused parameter thing because yeah, that's gonna drive me crazy. There are macros to deal with it, and they're messy. That's what I want to say. So we're going to edit a file called include macros, maybe. Sure. And let's give this a name, or well, we need to do this anyway. If not defined Tang macros HPP pound define And I'm copying this from code that I've used in a million other places, and I don't even know where I got it. So, one moment. Oh, that's why. :set paste. There we go. No, it didn't. All right, so if we do this, if we just say Tang unused, whatever, and it should work for several different types of compilers, even though I'm only technically writing against one compiler at the moment. So now I've got this macros.hpp, and let's go back to, I'm having a problem with ast.cpp, and that is 5. So buffer 5. What is, oh, because I've got a caps lock on. I have to do the same thing here, and I have to remove it when we do actually start using it. Of course, forgot to include them. Macros. Okay, no more, what was it called? Segmentation faults. All right, so where we are now is that we've asked the AST node, whatever it is, to compile its contents. Simple enough, we'd think, right? And because we're using pointers and we've got a virtual function here, we know that we've got this integer 3 thing going on. We know that that is the root. It's just an integer. And so now we want to be able to the integer should be able to compile itself. Now, how can we do this? Well, first of all, the program dot, what did we call it? Opcodes. We can push back op integer. No, op integer. this val because, and we're going to specifically say we're going to bitcast it as a uint64t. Now, bitcasting is something new as of when, Corey? I don't know. That's a very good question. I think it's C++20, C++ bitcast. And yeah, C++20. It requires that it's a safer or a I hate to say safer, but for type punning, right? Changing the type of a value, because our opcode is a 64-bit space, and we're going to have to put something in there. So we're putting the opcode. Now, for that matter, it's probably not going to like the fact that I just tried to do this here. In fact, I'm expecting it, and I don't know. That's why I'm not changing it yet. But I think it's going to give me an error on this op integer. Either I need to add program : op integer or something. But also, I probably am going to have to explicitly cast it to a uint64t. But if I write that, bitcast is not declared, of course, so I need to pound include bit, and program is not declared because I said it was unused. So let's, and now as a member opcodes. I don't remember what I called it. 4. Oh no, these are the AST nodes. I'm on the look at the wrong thing. Program.hpp, that's 2. Bytecode, but it's private. Bytecode is private, which means, and I don't want to expose it, I will need to add a function that is I don't want to say byte because it's not. It's actually, it is a uint64t. To the bytecode. Sure. All right, and this is going to be, we're going to say it as a void, and it's going to add bytecode. So I've got this add bytecode now that we need to provide, and that's in program.hpp. And that is, so program.cpp is 3. So should be not E, but buffer. I think it's 5. Yes. So it's program dot probably got the name wrong. Op integer, and this should be probably a program op integer. It's not. What did I call it? Called this oh, it's in opcodes, right? Opcode singular. And I think opcode should be singular instead of plural. So B1, BD, that should get rid of that buffer. So buffers, yeah. Let's just not source, include, and let's move opcodes to opcode. Yeah. I think I'm going to like that better. Okay, yep, good, good. You say good, it's giving us an error. Yes, but it's the error that I was expecting. It says it can't convert that. So let's I don't want to. I think it's still going to give me the same. So op integer is not declared. That should. It's not a namespace. Okay. Either way, still have to do this. So if I explicitly say uint64t, I've never tried this, so we're going to see if it works. Yay! All right, so we have supposedly added this bytecode, but we don't know what it looks like. So that's what we're about to do. So we need to be able to dump our bytecode. And what better way to do that than write a dump procedure for dumping the bytecode. And so we need to go into the program dot. Okay, so buffer 2 and then buffer 3. Buffer 2, we're going to, we've got get code that returns a string. We're going to let's get AST. Rather than get, I probably should say dump. Okay. Formatted like assembly. Sure, why not? And it's going to return Should I make it singular or plural? Down here, this protected. Oh, bytecode. I should call it bytecode, not opcodes. Bytecode, and that makes sense because you normally just say bytecode as a singular. So there's that. It will be a const. And now go to buffer 3. There we go. And I know we're going to need iomanip for this. Are we? Yes, we are. We'll need iomanip. And In case you're wondering, I just got very silent. It's because I know I've dealt with this problem before, and I just kind of want to see how I solved it. Yeah, okay. Let's do this in a couple of iterations. First of all, we're going to have size t program counter, PC. And I think I want my opcode width to be 12. That should be wide enough. And so while my program counter is less than this arrow bytecode dot size. So while it's that means I'm about to print out something. So my okay, that's right. I don't want to use a string. I want to use a string stream for the output. And why? Because I'm going to feed in, let's see. I think I want to put the PC number there. So what's going to be the biggest number? Of course, how do you, question I asked my students a couple times, like given a number, how do you know how many digits to make it, and how many digits wide you need? Like 10 that you need 2 digits, or 7 that you only need 1 digit, or 3,000 that you need 4 digits. And of course the answer is log base 10. So for that we're going to need CMath. All right. And now I think I prefer having that there, and to have offset width, and this will be well, let me back up into it. Well, no, I think I can do it. I always want the number raised to an integer, so it's going to be the ceiling of the log base 10 of bytecode size. That should be right. Okay, now what do I do with that information? I set my width to my offset width, and I want them to be 0 filled. Yeah. So how do we do that? Yeah, set fill, and it's a char. And I want it to be right justified, and the program counter. No, yes, the program counter. So it's going to start off with a value of 0. All right. And now I need a space. That should be fine. Set the width to the opcode width. Oh yeah, no longer want the zero fill. I want the set fill to be nothing. And I want it to be left justified. Okay. Now, at the end, I'm going to want to do out end line. Okay, now what do we do in the middle? So the only thing that's left now is that we need to... You know, I don't know if I can do this on the... Well, we're going to try it. SWIT switch. I hope we can. On the... This bytecode sub I, not I, PC. And we'll do case op integer. What do we do when we get to an op integer? Now this is my style. I will always put everything. I don't like that alignment. Sorry. If you prefer a different alignment, giving it the name. And PC plus 1. And then PC plus equals 2, right? Because, yes, we're skipping by. So it should output the integer, and then bytecode plus 1, and it's probably not going to like a lot of stuff that we did about this. Oh yeah, it's not going to like this, but is that right? Is it just str? There's several things here that it doesn't like. It doesn't like going from a double to an int. What's funny is we can do this explicitly and get rid of that error. Op integer, it doesn't like that. I'm wondering, I tried this a moment ago, didn't I? Namespace, Tang, but I didn't try it this way. Tang program. No, it just doesn't like it. I really hope I don't have to do this the entire time, but... give me a second. Let me... I'm in number 3. How did I do this in number 5? Oh, just opcode colon. Has not been declared. Program, and program includes that, doesn't it? Oh, of course, it's, I don't know why I was trying to put it in program earlier, because I was thinking about the code type thing that we had to put in program. Okay, so pound include opcode.hpp. Okay. And now, can I cast this to an opcode is the question. It allowed that. Okay, 65. Other mistakes you don't want to make. There was no break. Is it case default or default? I guess it's that. All right. Now we want to see if we can dump the bytecode. And that's going to be in test CPP, and dump bytecode. Is that how I did that? Yes. All right, and now, so program.cpp, that's in buffer 3. The only thing we need to do is, don't know what I was thinking, because that definitely does not need a space. Oh, I don't need to add a space after op integer because I set my width up here to be 12. So that's fine. I can live with that. So now what we've got is the ability, well, doesn't look that impressive, but it kind of is. We've got this, we can dump the AST, and now we know that we have created a bytecode value of 3. Now, due to time, where are we? We're at, an hour in. So, I'm not going to go too much farther into this. Because we still want to be able to execute it, right? So, but this is the basis for compiling. There's a few things that we could probably do. In fact, I think I want to add that really quick, and that's just to be safe. Ooh, wait. Do I want to do it that way? No. Okay. What I'm thinking, and I'm going to just mull it over, is you notice here. Basically, whichever bytecode we're on for the program counter, we're reading one past it. We need to verify that that exists, otherwise we could have an error. But we're going to have a lot of these types of things. So we need a little macro, really, to say, hey, if I'm reading past it, do some sort of error. Actually, I know how to do it. I know a good way of doing it. I don't know how to document it, meaning with Doxygen, but I'll figure that out. But if I do a define and program check dump. So this is I'm in the dump. In fact, a better wording would be dump program check X. What am I doing here? I'm going to say if this init opcode dot size is less than the program counter plus, and you always put that in parentheses. If that is the case, then return, and what do we call it? Out.str plus opcode truncated. I don't need a semicolon. Okay, and now dump program check is the name. The very first thing you do is and how many? How many more? I don't need to check for the current one, and I'm saying, so I need, is there one more value? Yeah. That should compile. It's not opcode, it's bytecode. It works. All right. So why did I add that again? It's just because we're going to need that over and over. When we go to executing, we'll do the same check. We will also have to check the size of the stack to make sure that I'll be talking about that more with how we're going to, what our execution model looks like, and that is we'll be using a stack. I've tried several different ways. Like I said, this will be the third time that I've written this project, and I've tried several different ways of representing the computed values. And I've I know how I don't want to do it. I don't want to use shared pointers. I like the idea of shared pointers, but they are incredibly slow. That's the first thing. So then the second thing is, well, what can I do? So then I thought about, well, what about using raw pointers? I was like, well, I'd have to keep track of the memory pretty well. And then I thought of all the different ways that values need to be manipulated and potentially copied or not copied. Just copy a pointer, but as long as you don't, do a double delete on it, you're okay. But it's always keeping track of which ones do I need to delete and which ones do I not need to. I thought about writing my own thread pool, not a thread pool, memory pool. I thought about, I did do a small proof of concept on doing my own reference counting container. One of the reasons that shared pointers are so slow is because there's a lot of locking for being able to do thread safe operations, even if you're not using thread safe code. And that's a point of contention around some people with this, because one of the big things about C++ is usually you don't pay for abstractions that you don't use. But in the case of shared pointers, no, it's always doing the thread safe checks, and there's no way around it. We don't have an option at this moment. We don't have an option that bypasses that. Anyway, all that's to say is we want to be fast. I've written this so that it does a lot of small allocations, but that's actually bad when you're trying to do a lot of operations. So not thread pools, but object pools are a workaround, but then that adds different complexities, especially because we've got so many different types of objects. Yeah, I'm still not completely settled, and that is the next step, and it is huge because that's how the rest of our program works. But as of this moment, we have code that gets parsed into an AST, and now the AST will compile into bytecode, and we can dump either the AST or the bytecode. Now we've only got one operation, this op integer, that will push the value of 3 onto the stack as a computed variable. But it's how do we want to represent that computed value? That's the problem, and that's what I'm going to be working on. So I may be on Twitch. Like I said, I think I just want to stream just to keep me focused on what I'm doing. But I'll probably be writing several different small proofs of a proof of concept, several small ones in different ways, and just to see which way do I like better. And then I'll make a decision, and that'll be the next video. So, all right, I'm going to, as usual, go back, finish adding documentation, get this uploaded, and it'll take me, I guess, another hour to do or so. But above all, programming is its own reward. So I'm hoping that it's maybe something educational for you, or just something to play in the background. I don't know. But either way, have a great day, and until next time.